Okay. Technically, this is the first section of Chapter 8. And when we deal with that, what we're looking at is using the radicals, the square roots that we did the last lecture, and we're putting them to work in solving sides of right triangles. The first thing we have to do is introduce a new term within an old concept, okay? And it's called the geometric mean. Okay, so that's the first thing we'll be dealing with. We'll also be talking about how it comes into play when right triangles are in use. The resources for this, and I would recommend you go over these. The first are notes I put together dealing with geometric means. Okay? The second is the textbook PowerPoint, and also another good one. Okay, so here we go. First, what is a geometric mean? That's a rhetorical question, but one I will answer nonetheless. When you have a proportion and the two means, remember, extremes, means, okay, so when the means are the same number, that's known as a geometric mean. Let's think of an example, okay? Since proportions have to be equal, if I have 5 over 10 equals 10 over 20, both simplify to 1/2. The 10 is the means on both. That's what it is. So, B is the geometric mean between A and C. Okay? Questions you will be asked. You may be given this and say, find B. You'll have numbers for A and C. Or, given those numbers, they may say, find the geometric mean between, okay? In this case, let's say it's find the geometric mean between 5 and 20. We just did that. Cross, multiply, and solve. But we'll be dealing with square roots, which we'll see in our examples. Now, in applying these, here we go. When you have the altitude drawn from the right angle to the hypotenuse of a right triangle, okay? This, remember, is one of the altitudes. On a right triangle, you have 3 altitudes, just like any other triangle. However, this is the only one drawn inside the triangle. The other 2 are the legs of the right triangle. Okay, so you're looking for perpendiculars here. Now, the leg, the altitude, and the leg are geometric means when we set up our extended proportion. And the reason is that they have 2 jobs. Look, hey, I keep getting a pop-up on the screen, and it's just about going to make me frisbee the iPad across the room. Now, why is that? Look at the 3 triangles, okay? DAC is the entire triangle. BAD is this right triangle. BDC is this right triangle, okay? And what you need to deal with, and the reason those are listed, and that's the first thing we're going to ask you to do here, is to write a similarity statement. This is one for the 3 triangles. And we'll do another one on examples here in a second. But, okay? So what we have to remember is this. I put the marks in here so we would have an idea of what goes with what. And that's how I find, and that's just me, the easiest way to set up the similarity statement. Okay? If I have the angles, I already have the 3 right angles, so that's a good starting point. But then I'm going to look at the big triangle. So triangle ADC. I know that A and C have to be complementary. They have to add up to 90 because we've already got the right angle. And in any triangle, we have 180 degrees. So if the right angle is taken out, the other 2 have to add up to 90. Okay? For every right triangle. So if I know this one and this one add up to 180. Now, let's just look at this triangle. This one and this one. If I subtract the same number from 90, I'm going to get the same answer, regardless of how many times I do it, assuming I don't make any mistakes. So that means this angle and this angle are equal. The same holds true. In this right triangle, I know this. That means I know this. Oh, look, those 2 are equal. Okay? If you're having trouble following with just the marks, I'm just going to put a couple numbers in just so it makes a little more sense to some of you. Look at triangle ADC. If, for the sake of example, I say angle A is 40 degrees, that means angle C has to be 50 degrees, because 40 plus 50 is 90. Okay. Once again, if that's 40, that has to be 50. Two equal angles. On this triangle, we said this was 50. Means that has to be 40. There's the three triangles that we're setting up. Okay, and I've matched the angles. Okay. On these, as I said before, X, Y, and Z are geometric means. They play two positions. Okay, they're offense and defense. Okay? Because, watch, X is a leg of this triangle. X is also a leg of this triangle. Okay? Y is a leg of the big triangle, but it's also a hypotenuse of this triangle. Z is a leg of the entire triangle, but it's also a hypotenuse of this triangle. So we've got each of those three lengths doing two jobs. Okay? These pages right here, the top one, I lay out how to set it up. You'll look at it and you go, oh my God, that looks like play in football or basketball. A lot of arrows going around. But here's basically what it looks like. This leg is the geometric mean between this leg and this leg. Okay? This segment, okay, is a leg to leg, hypotenuse to hypotenuse. Same over here. The leg of the big triangle compares to the leg of the small triangle. The hypotenuse of the small triangle compares to the hypotenuse of the large triangle. I will write it out, and 50% or more of you will go, I have no idea what he's talking about. And that's okay. Until you start working on the problems, it's going to be not a difficult problem to solve, but it's going to be difficult to get until you practice it. Okay? It's going to seem very awkward. Don't give up. Keep fighting through it, and it will become easier. I promise you. Okay, here we go. I'm going to start with X. Okay? X is the geometric mean between this and this. Legs, legs. Okay? Okay, there's our first one. Okay? The Y is the geometric mean, as I said, leg to leg. It's also hypotenuse to hypotenuse. Okay? So, that's how we're going to write it. AB okay? And our last one over here, Z, same thing. Leg to leg, hypotenuse to hypotenuse. Some of you ask why I put the little whoop-de-doo on the Z's, because sometimes they look like twos and I don't want to confuse you. Okay? So those are your three, and this is kind of where the arrows come into play. Okay? Kind of looking like that. That's what we're going to deal with. So, geometric mean, statement of similarity for the three triangles, the geometric means, the leg, and the altitude from the right angle. Okay, let's go do some examples. Definitely going to be mandatory today. Okay. Okay, yes, and I did it right again. Okay. Find the geometric mean between 8 and 12. Okay? Okay, 8 and 12 are the extremes. The means are what we're looking for. Okay, x squared equals 96. We are going to take the square root of both sides. Square root of both sides is a mathematical operation, just like adding to both sides, dividing both sides. Okay, so once we do that, this becomes x. Now we simplify the square root of 96. Okay? As I mentioned in the lecture on square roots, don't jump for the calculator right away. This is a time when I want you to simplify. So get used to it. It's an exercise. Okay? You're going to figure out 96 is a really common one here. Okay? 96 will break down into 16 times 6. Square root of 16, and that's our answer right there. Okay? Practice these. Just like I asked you to practice the square roots. It's important. Find the geometric mean between 3 and 15. 3 is our first term, 15 is our last term. I use y on this one just because. Okay? 3 and 15 multiply to 45. The y's become y squared. Square root of both sides gives me y. Break down 45 into 9 times 5. Okay? Just like I did with the 96, I found the largest square that goes into it evenly. 9 goes into 45. 9's a perfect square. Remember when I said you don't have to memorize them, but if you're familiar with them, it's going to be easier? Okay? The square root of 9 is 3. This is the geometric mean between 3 and 15. Okay? Last example here. Okay? Find the geometric mean between 4/5 and 2. Ooh, a fraction. Fractions are our friends. Okay, I use z, because a, b, x, y, z, and I lack creativity. I'm going to multiply okay? 2 times 4/5, remember whole number multiplies the top. Okay? I'm going to take the square root of both sides. Okay? Now, remember we can't leave that inside. So, I'm going to separate it right now. Okay? Now, that's a problem. I can simplify that. I'm going to hold on for a second. Okay? I'm going to multiply top and bottom by radical 5. I showed you this in the last lecture. You're going to have to deal with it. Okay, so we're multiplying by 1 to change the appearance. Okay, so that's what we've got. Simplify this. I'm going to say 4 times 10. 4 is a square. 10, no perfect squares inside. That's how we're going to go. The square root of 4 is 2. And that's our final answer. Okay? That's how we deal with these things. Okay? Now, on this particular question, we have to write a similarity statement identifying the 3 similar triangles. Okay. We know we have one triangle, the big one. Okay. So let's just go with that right now. Okay. And however you want to start it out. Okay. I like to start with the right angle because it makes it a little easier. Okay, L, J, and K. L is the right angle, so that means I'm going to match that with this one right here. Next, I'm going to mark the angles, so I make sure I'm putting things where they belong. Okay. There's that angle and that. Okay, so J was the green, K is the orange, just for the sake of this. Until you get comfortable with it, this might not be a bad idea. Okay, let's match. So if that's green, that's 90, that's orange. If that's orange, that's 90, that's green. Okay. How you choose to match here is up to you. You may do it this way. Folks, I'm going to be honest with you, it's not a bad idea to just line them up. Oh, okay. Since I said right angle, I start with right angle. I went to green, I stay with green. I went to orange, I go to orange. There's the second triangle. It is similar to my third triangle, this one. Right angle, right angle, right angle. Green, green, green. Orange, orange, orange. There they are, lined up properly. You're pretty much done. Okay? That's just a practice one. Just make sure you're putting them in the right place. Okay, now we're going to start with solving these. Okay, there's that splotch again. Okay, find the value of x, y, and z. X, y, and z. Just like we did on the first one. Okay? I have the numbers 8 and 23 as segment and segment. I need to find the entire hypotenuse. So what is 8 plus 23? There we go. Okay. So let's just use green right here. It doesn't matter where you start since we're asking for all three of them, okay? May as well just start with x. So 8 and 23. It's between those. Cross multiply. Okay, here's the first of your, wait, I can recognize that. 23 is a prime number, correct? If I multiply it by 8, okay, I'm going to have to deal with that. If I don't multiply by 8, because 8 already has a square in it, it makes life a little easier for me. And it'll become even easier in the next couple of problems when you're dealing with perfect squares. So here we go. I'm just going to say 8 times 23. Okay? Square root of both sides. Nope, still not multiplying. Now we can finish up. Now, many of you are jumping out of your chairs because I know this excites the heck out of you. Oh my God, 46 is an even number. True. Does it have a square in it? Not as one of its factors. 1 times 46, 2 times 23. That's it. We're done. Okay? Okay, next one. I'm going to go with the purple here. The y. The y is the geometric mean between 8 and 31. Exact same thing I did here. Okay. Okay, 62, trying to think. 1 times 62, 2 times 31. 4 doesn't go in evenly. Nope, nope. That's it, we're done. Okay, and your final one, the z. And separate these for you. Okay. Z is the geometric mean between 23 and 31. Okay, now this is when you go for your calculator. Okay? I had that sitting here. Okay, so, or we can do it the old-fashioned way. And we can go ahead and leave it. Okay? That's the first one. Okay, next problem. On this one, we have that segment, the hypotenuse, we need this segment. So what we're going to have to do is subtract. Okay, 25 minus 6. Oh good, another prime number. Not going to be horribly difficult here. Okay? So, Once again, I'm just going to go in alphabetical order just because. Okay? Okay? Sometimes that's what we get. Okay? I did not choose easy ones. I chose ones to make us work a little bit. Okay? Even me. So here we go. Next one. Okay? Problem 6. 5. Okay? Okay, so we go to the Y's. Now, this is an example I told you about. 25 is a perfect square. If you multiply it in, you're going to have to divide it out. Why? Okay? Work smarter, not harder. Square root, both sides. Done. Okay? And then we'll go to our Z. Okay? Right there, between 19 and 25. Same thing, 25, don't multiply it in. Perfectly acceptable. Yeah, in each of these you're getting 3 problems for the price of 1. So no, you're not going to have to do a ton of these. Okay? Last one. Oh, wait. We've got to find this. That's our Z. It's not a geometric mean. The X, not a geometric mean. Okay? The Y is. I'm going to start with the X here. Okay? And you'll see why in a second. Okay? So, for problem number 7 here. Okay, however you want to work it out. So, okay, 9 over 2. I'm going to leave it as 9 over 2 because when we multiply things out, okay? So, what does that make this? Well, to be over 2, okay, that's going to be 4 over 2. Okay? So that means together, I've already got 2 of my answers. Okay? And I didn't have to do squares or square roots. Now for this one I will. Okay? So for the Y, I've got 2 over y equals y over 13 over 2. Yes, this is going to work out nicely. 2 times 13 over 2 is 13, square root. And there we go. Yeah, you're looking at it and you're kind of confused. Watch the solutions a couple of times and then practice, okay? Go over the notes I've given you, okay? And go back through these. They're going to make it easier for you. It's not going to be easy the first time you do it. Trust me on this, okay? You're going to look at it, you're going to get confused, but once again, don't give up. Plug through it, okay? And if I see anybody just putting down a bunch of just straight answers on their homework, I'm giving you zeros. You need to work through these, okay? You need to work through these, okay?